both shear force and bend moment diagram of physically determined beam as shown below. So let's discuss statically determined beam. What are physically determined beam? Physically determined beam are those beams that are determined using the condition of equilibrium. What is simply the condition of equilibrium? First start is that the condition of equilibrium are three. One is that summation of particular components are always sum up to zero. Second one is that summation of particular components are always zero. And lastly, moments at any point are always zero. That's the three condition of equilibrium. So let's first, when I solve this question, I need to get the reaction, right? So I will name this part as C. My first start saying that this is a cantilever beam. Why? Because the two edges are not resting on support. So hence, we call this a cantilever beam. That's the first task. My second task is that I need to name this A and B, also name for the parts. So I'll name this as A. This is my point A. My point B at this point. Let me call it C, D, and E. You can just choose to name it anyhow, but you can just name it A, B, C, D, and E. That's the first task. My second task is that now I need to draw I need to calculate for the condition of equilibrium. My first task is that we said the condition of equilibrium, we said horizontal components are always what? Zero. Hence, in this case, there is no horizontal component here. They are all vertical. So hence, I will ignore the first law of equilibrium. Starting with the second law of equilibrium, that says that the summation of particular components is equal to zero. Hence, I will consider upward force to be positive and also downward force to be negative. Hence, what do I do? Here's the idea, please. So, coming to for your solution of particular components, we said whenever I see any force going upward, it's simply what? Positive. Any force going downward is what? Negative. Hence, let's start with this one here, right? This is 20 what? 20 kilonewton. So I'll have 20, right? Which is coming downward, which is what? Negative. Hence, comes minus 20. This is going upwards, right? So let me call this RA, right? And let me call this RB. Why? These two are called reactions. Hence, I can call it reaction at what? Point A. Reaction at what? At section B. So I'll have this going upward. And you said upward by what? Positive. That becomes plus RA. This is going downward because what? Negative what? 70 kilonewtons, right? Also upward, set positive, that becomes what? Plus RB, right? Minusing what is coming downwards, so it's a minus 20 is equal in value to 0. Hence, I'll do the needful here. I'll be having this is RA, right? Plus what? RB. Hence, I'm left with what? Minus 20 minus 70 minus 22 is equal in value to 0. Hence, I will do this here. I'll have RA plus what? RB is equal to when minus 20 plus the equal sign becomes what? 20 also plus 70 plus 20. Right? So if I sum of this, I'll have RA plus RB is equal to 110 kilonewton. I will call this what? Equation 1. Right? I'll call this equation 1. So we said we know equilibrium are just three. We know the first one, which is what? Summation of horizontal components is equal to 0. We know it because in this question here, there is not horizontal component. Hence, we started with what? Vertical components. The next task now is what? Let's get our moment. So, target for moment, right? So let's take note that taking moment at now listen please. take moment at a point when you know that it has what two reactions. Now in this case, I can decide to take moment at point B, at point B or at what? At point A. So hence, if I take moment at point A, perhaps it simply means that every force acting at that section is zero. So because moment is telling me that anywhere I take moment from is always what? Zero. So hence, if I take moment at A automatically what? Zero. Right? So now let's take note at section A, or perhaps at section B, your choice, right? So let's just take at section A. Take moment at section A, right? Which is this. So we said that the solution MA is equal to what? Zero. Hence, consider clockwise towards positive, clockwise towards negative. So observe that please. Your clockwise direction should be positive, while your anti-clockwise should be negative. That's all. So now, how do I get the solution or perhaps the moment of section A? Now we said anywhere the moment form is always what? Zero. Hence, this point here is zero. It's off, right? It's off. I don't need the thing. Now here is my illustration of moments. Here's my illustration. Let's say, for instance, they are meant to share, let's say, 3 billion, perhaps 3 billion at this point. This is, let me say, this is the person C, the person D, person B, and person E. Everybody in Nigeria now is right. So, if I want to share 3 billion at this section, this man here will come here to collect his own. This man here will come and collect his own. This man will come and this man will come to that section. Hence, now we are considering set moment. What is moment in physics application? It's simply the what? Force times perpendicular distance. That's all. So now observe at this point here, this man here, let's have this man. We said solution A, right? Solution M is zero. So at section A here, yes, automatically is what? It's zero. It's off. Now let's start with this guy here. If this man here, section C, wants to come and collect 3 billion at this section, how will it move? What is the fastest way for it to move? Will it move like this or just like this? It will move in this pattern, right? In this pattern. Hence, what kind of direction is this? Is it clockwise or anti-clockwise? This is anti-clockwise, negative. Hence, it becomes what? Minus 20 multiplying what? It says moment is what? 4 times distance. This is the force. Hence, what distance? From where to here is what? 1.0. That becomes what? 1.0. I have that. It's off. Right? I'm done with that section. Put the positive sign into, that is right. Let's consider section D. Section D2 will come and collect 3 billion at this point. How will it move? Will it move this manner or this manner? This manner is what? The fastest way for it to move. Hence, what my direction is clockwise direction, positive, right? That becomes what? 70 multiplying this time going to is what? 1.3, that's all. 1.3. Have that. Hence, I've done from section C, section D. Let's do section B. At section B, listen. At section B, will section B go this way or this way? It will move what? In this manner, because it's what? The fastest way for it to move. Hence, I have what? Plus into this and clockwise, right? Minus what? R B multiplying from here to here is what is. From here to here, this police is 2.6. That is 7. 2.6. 3.6, right? That becomes 3.6. That distance. It travels from this section here to this. Sorry, no. It's not from here to this point, right? It's at this point. So it's what? 2.6. 2.6. So yes, the idea is it's section B travels what? A distance of, they are showing 3 billion here. So distance from here to here is what? 2.6. Multiplied by what? The fourth there is what? RB. I have that here. Also, now let's go to section E. Right? Section E. So what do I do? Section E, it moves what? In this format. This is what is into 20 multiplying what? From year to year now what? 3.6. 3.6. So that is half take moment for a section. So now let's do our very respectful terminology. So we're having, now listen, here's the idea. Minus 20 times 1.0, I still have 1 minus 20, right? So I have minus 20 plus into 70 multiplied by 1.3. 70 multiplied by 1.3. I will have 91, right? Plus into minus RB multiplied 2.6. It becomes what? 2.6 RB. Why? It is correct if you say RB 2.6 is correct, but it is not proper. In mathematics or in science concept, number comes before acronym. So I'll be having 2.6 minus 2.6 rather 2.6 RB. That's all. Also I have plus into 20 multiplied this value. 20 multiplied this 72. I have 72 at this point. That's all, right? So it's equal to 0. Why? Summation MA, moment at section A are all this, right? Equal to 0 is this. That's all. Let's go on this thing. I will have equal to minus 20 plus, multiply by plus, say what? Plus 91 plus minus what? Minus what? 22.6 RB plus 72 is equal to 0. Now I can see that RB here is what? Is separating itself. So I can just take this my 2.6 RB to the equality sign becomes what? Positive 2.6 RB. I'll have minus 20, right? Plus 91 plus 72 is equal in value to minus 2.6 RB. Sorry, plus 2.6. Why? When negative crosses the equality sign becomes positive. That's all. So if I do my this quantities, minus 20 plus 21 plus 72, what is it? 143. That's all, right? So it's equal to what? It's equal to what? 2.6 RB. Now I want to get my RB, right? So getting RB, that becomes what? Divide through by what? Divide through exactly by what? 2.6. That's all. 2.6. 143 divided by what? 2.6 is equal to 2.6 RB divided what? 2.6. That's now my RB what is? My RB is now equal to what? 143 divided by 2.6. Hence, think about this. 55. My RB now is equal to what? 55. Alright? Kilonewton, please. Kilonewton. Please put value there. Kilonewton. Now I've gotten my RB. Observe from the question I have two things there. RA and RB. I've gotten RB. My next action is to go to what? Get what? RA. How do I get it? Let's recall from equation 1 from this guy. So recall from what? From equation 1. Which says what? RA what? Plus RB exactly is equal in value to what? 110 kilonewton, right? So let me just begin with Newton. After getting my value of opening it up, attach Newton to it. Now I know that my RB now is what? This man here. So hence substitute value. I will have RA plus 55 is equal in value to what? 110. Hence take this on the other side. I will have RA is equal to 110 minus what? 55. Give value. RA is equal to 55 again. So I have 55 kilonewton. Hence my reaction now I have RA to what? 55. Also my what? RB is what? 55. Please add it together. 110, right? 110. I mean, now add all this together. So this together. 110, right? So that's how to check if you are correct. Add your answers together, 110. That's all. Add all these forces together, 110. That's all. It means that this beam now is not in balanced state. In balanced state. So these are the part for the action of this question. Now, we are not sure. Let's get a shear force and bending diagram of this question and let's express this matter.